Welcome to Carlton's Math Corner. Today we're going to continue our study of greatest common factor. And we're going to actually look at some word problems that would point us in the direction that we need to find the greatest common factor. Okay, so let's read this first word problem. It says the cheerleaders are making spirit ribbons. Those are kind of like those ribbons that are different colors, probably the colors of your team, that they pass out and they sell to support your team. You know, you wave them at a game, and so they are creating them to sell and to pass out to everybody. And it says blue ribbons come in 24-inch spools. Spools are like those, is what you see ribbons come in, like they're round and the ribbon is tied, or it's wrapped around it. And so that's what a spool is. So this one comes in 24-inch spool. So there's 24 inches of blue. Red ribbon comes in 30-inch spool. And I'm going to start underlining as we, oops. I'm going to do, okay, so blue, 24-inch spool. Red, we're going to do pink, comes in 30-inch spool. And gold comes in 36-inch spool. Okay, so we have 24 inches of blue on one spool of ribbon. Red, 30-inch spool or 30 inches of red ribbon, and then 36 inches of gold ribbon. The cheerleaders want to cut the strips of equal length and use the entire spool of each ribbon. What is the length of the longest piece of ribbon that can be cut from each spool? So they're trying to make as many ribbons up as possible, but they want to make sure that they're all equal length. Okay, whether it is blue, red, or gold, they want to make sure that they're all cut in the same equal length. And so when I look at this, since I am cutting these into equal length, that actually clues me in that I need to choose a factor that is equal among all three of these numbers. And so I'm looking for a number that they all share, and I want the greatest factor that they all share because I want to get the longest, ribbons that I can get out of these, out of the blue, red, and yellow, or gold, I should say. Okay, and so let's look at these numbers and let's figure out how many ribbons, or how many inches our ribbons are going to be. Okay, so let's think of a method that we want to use. We can either use factor tree, we can use a Venn diagram, or we can even use a list method or like a rainbow method. We have three numbers. Which way would you like to use? Well, I'm going to actually do the list method. Not saying that that is the best method in this case, but I'm just going to go with it. And so I'm going to start listing. Here are all the factors of 24. Here are the factors of 30. And here are the factors of 36. And if you notice, if I start at the end and I work my way back, they all share 6. And they share more factors, but 6 is the greatest one that they share. And so I know that my ribbons, no matter what, are going to be cut into 6 inches. So whether they're blue, gold, or red, I'm going to all cut them into 6 inches. And so I need to figure out, because look at the question, it says, what is the length of the longest piece of ribbon that can be cut from each spool? And we figured out 6 inches. And then look at the question below. It says, how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces? So let's say blue, I cut them into 6 inches. Okay, so I have 6-inch pieces. How many of those ribbons will I get out of that 24 inches? How could I figure that out? Well, it's 6 inches per ribbon, and I'll just say that it's R. Okay, so it's 6 inches per ribbon, and I need to equal 24 inches. So how many ribbons will I get? You are absolutely right. I will get 4 of them because I know that 6 times 4 is 24. How about red? So let's switch to red. If I know that each one is 6 inches and each ribbon is the same, and now I have 30 inches of red ribbon, how many ribbons will I get? You are right. I will get 5 red ribbons because 6 times 5 is 30. How about our last one, gold? So let's switch. Gold, I have 6 inches again per ribbon, and it's equal to 36. And so how many ribbons will I be able to create that are gold? 6. Excellent. And so, and I'm just going to put, because I want to label these, I'm just going to say ribbons. And all of these are ribbons. And so I would get 4 ribbons in blue, 5 in red, and 6 in gold. Nice job. And here's another way of knowing how to do this. If I'm solving these equations, this is 6 times something is 24. So the opposite of multiplication, or we call it the inverse of multiplication, is division. And so if you notice here, here's my work. 24 divided by 6, I get 4 ribbons. 30 divided by 6 is 5. And 36 divided by 6 is 6. Our next problem. Kiara baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. The same number of each kind of cookie. Okay, so let's, first of all, 30 oatmeal, 48 chocolate chip. It's making me hungry. And we want the same number of each kind. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? Well, first of all, looking at those numbers of 30 and 48, I know that they're related to each other because they have to do with cookies. And I know that I'm trying to find the greatest number of each of those types because I'm going to put both of them in a container, and I want the same number of each in each container, probably to give away to friends or you know, and so if I'm giving them to the friends, which is so sweet, I need to figure out how many of oatmeal cookies and how many chocolate chip cookies I need. So this time I've decided I'm going to do a factor tree for each one of those because I'm going to try to find the greatest common factor of the number of cookies. And so here's 30 cookies for oatmeal, 48 cookies for chocolate chip. And so I broke them down into their factors. 3 times 10 is 30. Then I noticed 10 is still not a prime number. I can't stop. This one I can stop and put a circle around it because it's prime. But 2 times 5 gets me to 10. Prime numbers, I can stop. Now I am over at 48. 4 times 12 is 48. And then break it down further. 2 times 2 is 4. Prime numbers, circle them. Then 3 times 4 is 12. I can circle this 3 because it's prime. And then lastly, 4 is broken down into 2 times 2. And those are prime numbers, I can circle them. And so I notice right away that they both share a 3 and they both share a 2. This one only has a 5 left, and I notice that there are no 5s the 5 is not a factor of 48. And so I can't cross that off. And so the only two numbers I have is 3 and 2. So I multiply those together, and I know now that I can have not 6 containers, but 6 cookies of each kind in each container. So I can have 6 oatmeal cookies and 6 chocolate chip cookies in each container, and I will be able to use up all the cookies and then be able to share it amongst my friends. Now, last time you had to do this ticket problem, and if you did not get a chance to do this problem, please do so. I do not have a ticket problem for you tonight. Just please go back and review greatest common factor. Thank you so much for joining me at Carlton's Math Corner. I look forward to meeting with you again.